Hello students, welcome to the third part of current series Chemical Reactions and Equation. Today we'll talk about decomposition reactions and different types of decomposition reactions. So as the name suggests, decomposition means breaking down. So a reaction in which a single reactant breaks down to give simpler product is known as a decomposition reaction. So as you can see here, there is one reactant which is breaking down into more than one product. So essentially we can conclude that a decomposition reaction is just opposite to a combination reaction. You must remember that a combination reaction results in the formation of a single product, whereas a decomposition reaction starts with a single reactant. So how does a decomposition reaction actually takes place? If there is a single reactant, it has to break down, but can it break down on its own? I don't think so. It requires energy to break down into more than one product, and that energy may be supplied in different forms. Now let's look at types of decomposition reaction. So as I told you that the type of energy which is supplied will decide which type of reaction it is. So a thermal decomposition reaction is because of energy supplied in the form of heat. Then there is electrolytic decomposition where electric current is utilized, and the third one, photodecomposition or photolytic decomposition where light energy is utilized. Now let's look at them one by one. Thermal decomposition is because we are supplying energy in the form of heat. So thermal word, you know, it is associated with heat. So wherever heat is supplied and the reactant breaks down into its constituents or different products, we can say that it's a thermal decomposition. That is a decomposition which is driven by heat or which get energy from heat and is thus decomposed into its products. For example, we are looking here at calcium carbonate. On heating, it is decomposing to calcium oxide and carbon dioxide. Now these names you must remember that calcium carbonate is also known as limestone. Calcium oxide is also known as quicklime. So these will be very useful in the later part when you solve questions. These names, if you remember them, these will help you. Now let's look at another example of thermal decomposition. A thermal decomposition of lead nitrate. Now PbNO3 whole twice is lead nitrate. When it is heated, it results in the formation of lead oxide and the evolution of two gases. One is oxygen gas and the another one is NO2, that is nitrogen dioxide. Now this is the characteristic of nitrogen oxide gas, that is brown fumes are observed. So whenever you see brown fumes in a reaction, you can conclude that it is probably nitrogen dioxide. So this information will be quite useful in solving questions later on, that brown fumes are of nitrogen dioxide. So wherever there is a thermal decomposition and you are able to see brown fumes, you can safely conclude that nitrogen dioxide is produced in the reaction. Another example of thermal decomposition reaction is heating ferrous sulphate crystals, and let's look at what is going on here. Now this reaction is a two-stage process. First, ferrous sulphate crystals lose water on heating, and along with that their green color changes to white. Now in this stage only water of crystallization, these 7 molecules of water are lost, but in the successive steps, that is the next step, we see ferrous sulphate which has turned white already is now turning further into brown, that is, ferrous sulphate has changed into ferric oxide with evolution of these two gases, sulfur dioxide and sulfur trioxide. Now there is a unique characteristic of these two gases, that is, we can see here odour of burning sulfur. Now if you smell burning sulfur here, you can conclude that there are oxides of sulfur produced in any reaction. Here you can also see that green color on heating changes to brown precipitate. Now in intermediate step, as I discussed earlier, first it changes to white, where it loses water of crystallization. Those 7 molecules of water are lost, and on further heating then it is changing into brown precipitate of ferric oxide, along with evolution of these two gases, sulfur dioxide and sulfur trioxide. Moving to next type of decomposition reaction, here we have electrolytic decomposition. Electrolytic means we are breaking down something with the help of electrical energy or electric current. So we pass electric current through aqueous solution of a compound. What does an aqueous solution means? A solution in water. Now most common example of electrolytic decomposition is electrolysis of water. Now when acidified water is broken down into its constituent with the help of electric current, we have 2H2O breaking down into H2 and O2. So here O2 is missing, actually it should be O2 here. So how does it happen? Electric current gives the energy to water to break down into its constituent, that is H2, a highly inflammable gas, and O2, a gas which supports burning. Looking at another example, we can similarly break down sodium chloride, that is common salt, into sodium metal and chlorine gas with the help of electricity or electric current. Moving on to last part of decomposition reaction, that is photo decomposition reaction or photolysis. In these reactions, the energy is supplied in the form of light, that is photons. Photons possess energy, and thus this energy is utilized by these substances to break down into simpler ones. Let's look at an example, that is decomposition of silver chloride. Silver chloride is sensitive to light. On exposure to sunlight, it becomes silver. Since this reaction takes place in the presence of sunlight, it is also known as photochemical reaction. Now in this diagram, we can see there is a key placed over silver chloride and it is exposed to sunlight. Now this key, as we can see its impression here, due to the area that was hidden due to this key and the rest of the area is exposed to sunlight. Now this has changed from white to gray. Now white part is remaining in the area where key was placed because that part could not be exposed to sunlight. Rest every part is exposed to sunlight and thus has turned gray. Now you must remember these two things, that AgCl, that is sodium chloride, silver chloride, is white in color and silver on the other hand is gray in color. Now let's look at another example. Similar to silver chloride, silver bromide also decomposes in same way. The reaction shows AgBr on exposure to sunlight results in the formation of Ag plus Br2, that is bromine gas. Now, AgBr has a light yellow color and it turns into gray color. Similarly, hydrogen peroxide is quite unstable and in on exposure to sunlight, it breaks down into water and oxygen. So it can also be utilized as a good oxidizing agent because it readily produces oxygen. Now we must remember the color and characteristic of these compounds we have studied in this chapter. They will be very useful in solving questions in later part. Now you all know that NO2 gives brown fumes, ferrous sulfate crystals are green in color, while ferrous sulfate itself is white in color, ferric oxide is brown in color, silver chloride is a white compound, silver bromide is a yellow compound, and silver is grey in color. Let's decode certain questions based on our understanding so far. Let's look at this question. Ferrous sulfate decomposes with the evolution of a gas having a characteristic odor of burning sulphur. What is the chemical reaction involved and what is the type of reaction? Now, since we all know that it is a decomposition reaction, and which type of decomposition reaction it is, since it requires heat, it is a thermal decomposition reaction. Now this odor of burning sulfur is either due to sulfur dioxide or sulfur trioxide. So the solution to this question would be ferrous sulfate on heating decomposes to ferric oxide plus SO2 plus SO3 gas, that is sulfur dioxide and sulfur trioxide gas. The odor of burning sulfur is because of these two gases. Next question. On heating blue colored powder of copper second nitrate in a boiling tube, copper oxide, a colorless gas X, and a brown gas Y is formed. Now you must remember that Y, which is giving brown fumes, that might be NO2 gas. Since it is nitrate, copper nitrate, and it is heated, it is breaking down. So on heating something breaks down, that means it is a thermal decomposition. So copper nitrate is decomposing into copper oxide and the gases X and Y. Y we know that is brown gas, so it's NO2. Let's look at the solution. So copper nitrate is breaking down into copper oxide, nitrogen dioxide, which is giving brown fumes, and O2, that is oxygen. Now copper oxide, you must remember, is black in color. Y, the gas brown in color, is nitrogen dioxide. So this is the solution of our question number 2. Let's look at another question. A light sensitive compound. Light sensitive means which reacts in the presence of light. X of silver is used in black and white photography. Now we all know that we have learnt about two compounds of silver, silver chloride and silver bromide. On exposure to sunlight, its color changes to gray. Gray color is that of silver. So that compound of silver chloride or silver bromide is changing into silver. We have to first identify X, then write a chemical equation and identify the type of chemical reaction. Now since the reaction is taking place in the presence of light, it is photo decomposition reaction. Let's look at the possible solution. So since it is light sensitive compound X is silver chloride or silver bromide, the reaction is as follows. AgCl changes into Ag plus Cl2. Similarly, AgBr would change into Ag and Br2, and this type of chemical reaction is called photochemical decomposition reaction. So thank you, that's all. In next section, we'll talk about another kind of reaction, that's sulphur decomposition reaction. Thank you.